Here we have 2 multiplied by itself 5 times. This can be written using exponential notation as follows. In this expression, 2 is called the base, and 5 is the exponent. The entire expression is read as, you can read it as 2 to the 5th, or sometimes 2 to the 5th power. Power means exponent. So this is 2 multiplied by itself 5 times, written in exponential notation. Exponentiation is an operator. That is, it connects 2 numbers. Like if we write 2 to the 4th, they're connected by the operator of exponentiation. And we have other operators as well, like addition. 2 numbers can be connected through the operator of addition. Subtraction, multiplication, this is division, and exponentiation. And it's important that when we have an expression that involving these operators, that we do the various operations in a specific order. And that is called the order of operations. And this is the order of operations. First we do exponentiation, then multiplication and division, then additions and subtractions. And we do them left to right. Now, parentheses can change the order of operations. So let's look at a simple example. In this expression, we have 2 operators. We have addition and we have multiplication. And according to order of operations, we do our multiplication before addition. So this is equal to 3 plus 4 times 2, which is 8. And then we do the addition, 3 plus 8. And so this is equal to 11. If we did the addition first, we would get a different result. So that's why it's important to evaluate expressions according to the order of operations so that everybody gets the same result. Now, if we had meant to do the addition first, then we could change the order of operations using parentheses. So because we have parentheses around the 3 plus 4, we do what's inside parentheses first. All right, so this evaluates to 7. So here we have 7 times 2, and now we do the multiplication, and the result is 14. Here's another example. In this expression, we do exponentiation first. So first we do 3 squared. So this is equal to 10 minus 9, which evaluates to 1. Let's say we had the following, let's say we had 0 minus 3 squared. So we would do this, evaluate the same way. First we would do 3 squared. And so this expression is equal to negative 9. Now 0 minus 3 squared, we can write this as just minus 3 squared. So we see from the example on the left that we perform the 3 squared first. And so this is equal to minus 9. All right, or another way of looking at this, minus 3 squared, if we were to expand this, this is minus 3 times 3. The square applies to the 3 alone, not to the minus symbol in front. So we get minus 9 for that. If we want to square minus 3, then we need to use parentheses. So minus 3 in parentheses squared is equal to minus 3 times minus 3, which is positive 9. In number 1, we want to write using exponent notation. So this is equal to minus 5 to the third power. Okay, number 2 again, we want to write using exponential notation. So here we have 2 multiplied by itself 3 times. So this is equal to minus 2 cubed and then multiplied by 7 squared. Write in expanded form, so we're just going to multiply negative 4 by itself 5 times. Again, write in expanded form. Here it's important to realize that only the 7 is being repeated 3 times, not the minus symbol in front, and that's because of order of operations. Another way of looking at this is as follows. Minus 7 cubed we can think of as minus 1 times 7 cubed. So when written like this, it's more obvious that the exponent applies only to the 7, not to the negative in front. So this is equal to minus 1, and then we have 7 times 7 times 7. Or we could just write this as minus 7 times 7 times 7. Here we have an expression with a subtraction and an addition, and we're going to do this left to right. According to operations, we have to do these left. If we have many additions and subtractions, we do them left to right. Okay, so let's do that. So first we do 6 minus 4, which is 2, and then the plus 1. Here too, let's evaluate left to right. So first 7 minus 3 is 4. And then we do 4 plus 4, that's 8. And finally, 8 subtract 2 is 6. In number 7, we have an addition and we have a multiplication. And according to order of operations, we do the multiplication first. So that would be 5 plus 3 times 2, that's 6, which is equal to 11. Number 8, first we'll do what's inside parentheses. So we have 7 plus 2 times 3 plus 4 is 7. Next we do multiplication before addition. So that's equal to 7 plus 14. And finally we get 21. In number 9, again, we'll do what's in parentheses first. So we have 8 subtract 2 times 4. And next we're going to do the multiplication. So that's 8 subtract 8. And that's 0. Then number 10 we can do 2 different ways. And okay, we'll start with the first one. I'm going to actually suggest that you do these the second way, but let's start. So we're going to, let me just rewrite this. We can start by doing this multiplication. So that would be 10 subtract, and 2 times minus 4 is minus 8. So 10 subtract minus 8. I'm going to keep it in parentheses just because I don't like writing minus minus. So here we have 10 subtract minus 8, and let's remember our rules for subtracting negative numbers. When you subtract a negative, you add a positive, so this minus minus turns into a single plus, and we have 18. All right, now let's look at another way of doing this. What I really prefer is that you skip this step. So let's rewrite. Let's say we have 10 subtract 2 times minus 4. Okay. So what I prefer you do is um, just imagine a plus symbol over here, like we did when we changed subtractions into additions. We imagined a plus symbol in between. So think of this as 10 plus 8. All right, minus 2 times minus 4 is 8. So I'd rather go straight to this line right here and skip this one. So go straight to 10 and read this as minus 2 times minus 4, and remember the plus sign in the middle. So go straight to 10 plus 8.